Okay, great. I will start then. So, welcome. This is my project from the DIT 650C research class. And it's kind of expanding on one that I did previously. So, the focus of this one is exploring blockchain support mechanisms for federated learning in heart disease prediction. So, kind of a healthcare focus. And there's kind of like overarching goals. It is a machine learning project, so I'll talk a little bit more about federated learning in a second to review it, but there is like a machine learning model that will be trained. Um, there's going to be some mostly focusing the blockchain part on providing transparent auditing and governance for this federated learning training process. And then there's also going to be a mechanism for rewards and reputation tracking for the entities that are participating in the federated learning. Um, so federated learning is basically a way of allowing multiple participants. It could be like different healthcare entities in the case of this project, but you could also do it with like different groups within one organization, or a lot of times they'll do it with IoT devices, like lots of devices collecting data and training. So it's going to be a machine learning model that we're training, multiple clients, and this is just a simulation for research purposes. So there's no like real patient data that I'm going to show you. There's no real healthcare entities. This is heart disease, heart failure data from the UCI machine learning repository is the data. So there's going to be federated learning simulation. Where blockchain comes into that is it's a method of creating a tamper-resistant record. In the case of the federated learning, we're going to use that to keep track of like who is participating in the simulation, what their performance looks like over time, making sure that like all of their metadata for the model training is correct and accurate so we can like go back and validate their contributions later. And then it's also going to provide us a mechanism for keeping track of their reputation, which in this case is going to be like, how are they performing over time? And are they providing valuable contributions like to the group so that everyone can benefit? The reward mechanism is just a way to incentivize that type of behavior that we want, where they're providing meaningful contributions. And then lastly, it's going to be all kind of like streamlined and wrapped up into an end-to-end workflow. So there's all these different moving parts, but it's going to be just like one simulation that runs. And so if anybody was in my presentation maybe like 2 quarters ago, I did do a federated learning simulation, and that one was really focused on just kind of like getting it set up. I did use the Flower framework, like getting it up and running and talking about sort of like the basics of how it would work in healthcare. But this one is different because of the focus on the blockchain and especially focusing on transparency, auditability, governance, and security, which is like really important for healthcare because we want to have all of these features where, a healthcare, like a hospital or something, could say, like, yes, like we can demonstrate to maybe a government entity that's auditing us that we're appropriately handling member information, that we can sort of demonstrate where our predictions are coming from, but without like exposing all of the raw patient data. So I wanted to start and just kind of quickly go over the components of the technology stack here. So the federated learning portion of the project is coming from Flower. This is an open source framework. And so it manages all of the coordinating the client training. So the clients will they'll get a global model, they'll have their own data that's like specific just to them that the other clients don't have access to. They'll train and update their copy of the global model. They'll send back the parameters. It'll get aggregated by Flower, and then like updates will send out, and it'll cycle through over and over again. And that's how they improve the global model. So Flower handles all of that coordination because it is kind of complicated. It's nice to have like a well-established framework to handle that part. But it's also a really flexible framework that you can incorporate other libraries and other frameworks with. So that's like layer one is the federated learning. And then for this project, I'm bringing in blockchain using Hardhat, which is another open source library and framework. This one is for blockchain development. It runs on Ethereum, which is like a pretty common blockchain. A lot of research art projects do use Ethereum in this similar type of sphere. And it includes built-in functionality for doing smart contracts, which is going to be important later, and I'll talk about in a second. But it's pretty easy to get started. I'm not doing like a real out in the public blockchain. This is just like my local environment as a demonstration. Um, and you can also customize it a lot with like writing your own scripts to make it do what you want it to do. So the last piece comes from Solidity, which is more of a programming language. It's used for writing smart contracts. And a smart contract is essentially just it's code that you use to say, like, if this event happens, I want this outcome to occur. So you can use it to say, like, if the client participating in our simulation does like this action, then like this outcome will occur. So that is commonly recommended in research articles that are looking at incorporating blockchain for federated learning is that you use a smart contract to help manage without having like one of the clients having to do it so that it can be decentralized and not have a bottleneck as you just automate it with a smart contract. So moving through to the workflow, I have some diagrams to make it a little bit more concrete and easy to understand what's happening without like showing you the code, which should, I think, be kind of boring and take a long time. Um, but so I got it in 5 stages here. So we're preparing the data, and the important thing for that is that we are giving each client sort of its own, they're in their own folders that is supposed to simulate their local environment. So there's no interaction there between the clients. They're all separate. They all have just like a chunk of the data that's been divided up for them to train on. And then once they've got their data, that's when we run a federated learning simulation. And so it does the whole training process. They all contribute, they all get updates each round to improve the model. And then after the simulation, now we want to record the information from those training runs. And so I have some scripts to connect the federated learning part to the blockchain part, record all the information, and it gets passed to the blockchain where the smart contract then acts on information that's received, and it's all also stored so that you can go back and verify later and do like governance and auditing and different things. So I don't love using ChatGPT, but I hate making diagrams. So I had ChatGPT make me a diagram based on like the components that I told it of what's in the project to make it easier to visualize. So we've got flower here, and then we have our like stuff that we're combining, the custom scripts, and then hard hat solidity output is kind of like the stages that it moves through. So the Python is really being used as like a bridge to connect these two layers here. I wanted to, does anybody have any questions about kind of the setup before I talk about like more of the details? Okay, I will continue. Wanted to talk a little bit about the details, some of the algorithms that are happening. So in federated learning, part of the process is that local updates are all aggregated to create the global model update. This is done using most commonly federated averaging, which is kind of just like a pretty simple averaging process. But if you want to look more into the details of how it works, this McMahon is like the one of the original articles on the topic. And it is a method that helps like reduce communication requirements by letting you kind of like do things in batches when you're updating the global model. The specific model that I ended up using was SGD classifier. It's a stochastic gradient descent classifier from scikit-learn. It's pretty nice because it has like different modes you can set it on. So for my project, I was doing just a binary classification of like, are they at risk of death from heart failure, yes or no? And so that's one of the options that you can set it to. And it is good for this type of federated learning because it lets you do incremental training rather than like retraining from scratch kind of every single round that you do. So that was why I selected that one. And then the smart contract, I have some more details about what it's doing. So it's not storing any patient data, and it's also not storing the models because they're really big. It's not necessary to store the whole model file, but it is storing model hashes, which you can use for security governance purposes to say like, hey, this is the model that we provided to you. You are using the correct model when you're submitting it back to us to make sure that there's no like tampering with the data or tampering with the model. So there's also the metadata from the training runs, which includes like which client is this, what number run is it, what was their performance in terms of accuracy is what I was using here, but you could have all kinds of different evaluation metrics. And then also uh, like the timestamp and different things for just auditing purposes. So this all gets submitted and then it's stored on the blockchain, and the smart contract is coordinating, especially for distributing rewards and reputation, which I will go to next. A lot of the literature on doing decentralized federated learning with blockchain talks about like we need to decentralize because it removes single point of failure, but we also need to make sure that clients are like participating in good faith, that they're not like submitting just kind of garbage data so that they can get the results without doing the work or so that they can actively tamper with the model. Um, so we want them to be like putting forth their best effort, but it's sort of difficult to enforce that. So that's where the reputation tracking comes in, is you can create a custom scoring system to say like, hey, this is how we know you're doing a good job and we're gonna give you some kind of a reward based on that. So for mine, I was doing it based on their accuracy, as well as like changes over time. So like maybe they started out and they did okay, but then they showed significant improvement. In the next round, they get rewarded for that. You can also add penalties to say like, oh, your performance has been much worse this time, so we're giving you a little penalty, and a lot of the studies would reward them with like actual cryptocurrency as an option, but you could set up whatever agreement you want with your consortium of people to say, maybe it's like a financial incentive or like maybe it's access to like earliest and best model updates or something of that nature. So that is all managed by the smart contract. So everybody submits and the smart contract just takes care of it. It's very fair because everyone can see it, but nobody can tamper with it. Um, so conclusion and takeaways from this project. The blockchain was successfully added for transparent auditing and governance. The smart contract was really helpful in coordinating all the different moving parts of like keeping track of the clients and the data. The Flower was able to be integrated to handle the federated learning part of it. And so this overall shows how you can use blockchain in kind of a realistic healthcare model training setting to support accountability and client selection. But there's also a lot of limitations because I did this in like 1 quarter. It's a pretty small data set. So there's a lot of additional things we could do to expand this in the future. You could add more validation methods. You could do a lot more research into like what are the best variables to track in terms of client reputation. You could do a more advanced machine learning model, and you could also like try deploying it in production in a real healthcare setting and see how it works. So many areas that could be added on, but I thought it was really cool to be able to customize what I had started on previously. So that is, oh, that's references. That is all for now. Does anybody have any questions or comments?
Hello, Ellie. That was a nice presentation. I just have a few questions that I just want to ask.
Sure.
Uh, I just want to know why did you prefer FL over the other federated learning frameworks? I'm just curious why Flavor is best
Wildflower.
suited your yeah.
Yeah, it's one that's used a lot for like research simulations. And the reason why I liked it is partly because it's for free and it's open source. So that is really beneficial for students doing research. But also it has like an extremely involved like community of users and it has a really well documented code base. So it's really helpful if you're like trying to figure out how to set it up. I found like their tutorials to be extremely helpful, and just a lot of information online on how to like do the customization since I wanted to do more than just kind of like the out of the box basic tutorial type training. So those were my main reasons, but there are definitely other frameworks out there that you could use too.
Okay, that answers my question. Thank you.
Yeah,
Eli, thank you. Very interesting presentation.
yeah, thank you.
I'm glad that you are there is a continuity of
Mhm.
your study from what you presented 2 quarters ago. Okay.
Yeah.
At one point I was, I saw that you're presenting a different topic, so I was a bit concerned, but I
Oh,
think now you came back, so which
yeah,
is good. Yeah.
yeah.
Okay. One question I have is mm, maybe two. Mm, What kind of data set are you using? Because, for example, you're saying the Flower framework, it supports a large scale
Mhm.
federated learning experiments. So is the data set big enough? I mean,
Uh, the data set
um,
I used this time is not that big. I think it would be better to do it with a much larger data set, but just like given the time frame that I had to do it in is why I chose to use one that was like really clean already. It's from the UCI like machine learning repository, so
mhm,
it's already kind of like ready to go for machine learning, but
mhm,
I do think that it would be a good next step to kind of bring it all together and say like, okay, how does this work with something that's big enough that we could really get
mhm,
significant improvement over time with federated learning?
mhm.
Because I it really kind of maxed out early on in the training rounds, like how much improvement in accuracy there was. So I do think that that would be a good enhancement to make.
Okay, sounds good. The second question I have is, what is your contribution? So this is an interesting topic.
Hmm.
So if you could share with us what new approaches you're using compared to what you have seen before, that'll be appreciated.
Hmm. Yeah, I think one of the main things that I wanted to like research more and contribute this time is, there are a lot of articles talking about kind of like, yes, we need decentralized federated learning. Yes, blockchain like really makes sense as like the best way to do it. And we need client reputation tracking, but most of them kind of stop there. And there's not a whole lot, at least published yet. Like there could definitely be, things that are in process because it takes a while, but there's not a lot of like a design science approach where it's like this is actually how you would do a smart contract and maybe you could like moving on this more you could evaluate like what is an effective or not effective method of implementing that. Um so really getting more into the details of like how you would do this in healthcare instead of just like establishing that we need it, which we've kind of already done in the existing research.
Okay, thank you. Thank you for your response.
Yeah. Any other questions? I can also, do you want me to post the, or share the PowerPoint in the chat here? Would that be
That would be
useful?
wonderful. Yep, thank you. Yeah.
Great.
Giridhar, you're the